All right, folks, here is the big, the first really big lesson. So we're going to use the stuff that we learned in the previous two sections to kind of help us come up with these things. Good morning, Annalise. But what we're going to be talking about is where we're increasing, decreasing, and using our first derivative to be able to determine quickly where they're increasing or decreasing. So just going over basics, I mean, it's really this simple, right? We just have to remember that our first derivative is representative of our slope. So if I have a function something like this, right, I am increasing along this interval. So my slope is greater than 0. Therefore, I knew my function was increasing. So I could go from either way, right? I could tell that since f prime is greater than 0, my function is increasing on those intervals. My function is decreasing right there, and I know then that my slopes are negative. So I could have also said that since my slopes are negative, I had a decreasing function. It's constant when the derivative is 0, right? So if I had a function something like that, right? This part right here is where I would have f prime equal to 0. Okay, so using those characteristics, we're going to be able to state different things about our functions. So using the first derivative test, I'm also going to need to justify, and we are going to use something called the candidates test. We're going to have candidates that we check around to see where I'm increasing, decreasing, or neither. So identify the open intervals where the function is increasing or decreasing. So here, what I want to do first is find my critical values, find where it is equal to 0, and then I'm going to check around those numbers. So f prime would be 12 minus 3x squared, and if I set that equal to 0 to find my critical numbers, add the 3x squared over, divide, so x equals plus or minus 2. So those are my critical numbers. So now here is what I call the candidates test. Candidate right. This is going to check around my critical values to see whether f prime is positive or negative, and that will tell me whether f is increasing or decreasing. So the other thing that I like to do is I just like to say f prime and f. So all we're going to do is pick numbers around -2 and 2, and I'm going to plug it in to see what the slopes are. If they are positive, then I know I'm increasing. If they are negative, I know I'm decreasing. If they are 0, then I know I have a constant function. So say I choose -10 or something. All right, if I do f prime of -10, all that I really care about is whether it's going to come out positive or negative. So if I put in -10, that would be 12 minus 3 times 100, which would be a negative number. So my shorthand for this is minus VE, which just means all of that interval less than -2, oops, sorry, I'm backwards, less than -2 is going to be negative. And if f prime is negative, that tells me that f is decreasing on that interval, right? Because my slopes are going down. So if my slopes are going down, I need to have a decreasing interval. Then I will check something between -2 and 2. F of 0 is the easiest one, f prime of 0, right? So that would just be 12, which really all that I need from that is that this is positive. And if this is positive, that means that f is increasing. Something bigger than 2, I would check positive 10. That would end up just like -10, and this would be a negative interval. Minus VE is negative, right? So I have negative, positive, negative, and that means that my function here is decreasing. So that tells me the intervals, and when I state my intervals, I'm also going to need to state why. So let's take a look, right? I am decreasing on the intervals from -infinity to -2 and from 2 to infinity because f prime was less than 0. We need this piece as well. This answer would be like worth, they may include this as 1 point, and this would be 1 point as well. So you need that justification piece. Even though they aren't asking for you to justify, you need to state why you know what you know. Otherwise, you're just making a claim without a graph that isn't necessarily backed up. Okay, and then I'm increasing on the interval from -2 to 2 because f prime is greater than 0. And notice here, right, we do say the open intervals. That is because at -2 and at +2, those are my critical values. So my slope there is actually 0. So I'm neither increasing nor decreasing. But I don't need to list them as constants because they're just critical values. So they're just understood that at those points, right, I'm going from -2 to 2. So from -2 to 2, -2 must be a critical number. And then from 2 to 2, 2 must also be a critical number. It's kind of understood within the context of the problem. So we don't write that we have any constant values or anything there. All right, and that's essentially it, right? You need to state the interval as well as the justification. Okay, well, let's do another. So again, first my step would be to determine the critical values. So I would combine this into one fraction and set it equal to 0. So I'm going to have two types of critical numbers here. I'm going to have one where I have it undefined. So it's undefined at 0. That is a critical number. And then I also have it equal to 0 at plus or minus 3. So on my candidates test, I will have all of those values, so -3, 0, and 3, and I want to check around those. I will use my derivative, and I like it in this form, just because it's easy to think about for me. So if I put in, say, -10 again, like -10, looks like that is going to come out positive for f prime. So I'll say f prime and f and how they relate. So this is a negative interval. I'm just kidding, I said positive, but I wrote negative. Positive, that's positive interval there. If I choose somewhere in between here, like -1, -1 will come out a negative interval. +1 will also come out a negative interval. And then if I choose 10, that will come out a positive interval. So that means I was increasing, then decreasing, then decreasing, then increasing. So notice here, right, it goes from decreasing to decreasing. I also have a vertical asymptote at x equals 0, right? So I can't have that value at 0. So when I write my intervals, I have increasing from -infinity to -3 and 3 to infinity. I also have decreasing from -3 to 0 and 0 to 3. I need to skip over that 0 because it's not a part of my domain. Increasing because f prime is greater than 0, decreasing because f prime is less than 0. All right, I got to pause it because I got to teach second period, and then you won't even know that I did that. All right, back at it. I just met with you fools. You fools! I'm just kidding. I love you all. All right, so what were we doing? We were doing open intervals where the function is increasing or decreasing, right? So we're doing the first derivative test. That's right. That's right. I'm teaching math or something, yeah? Right. Yeah, cool. Awesome. Fun. Woo! Right, so f prime would be 2 sine cosine plus cosine of x. So now I need to find when that is equal to 0, right? So find my critical value. So I would factor out a cosine. So 2 sine plus 1. Cosine is 0. And 2 sine of x plus 1 is 0. Cosine of 0 is at pi over 2. And 3 pi over 2. And then I have sine equal to -1/2 at 7 pi over 6 and 11 pi over 6. All right, so we have quite a few numbers to check around to determine where I'm increasing or decreasing. Again, I'm going to think about my derivative in this form because it will help me the most, I do believe. My candidates are, let's do it in order, pi over 2, and then would come 7 pi over 6, and then would come 3 pi over 2, and then would come 11 pi over 6. All right, and I'm only going from 0 to 2 pi, so notice that. That's my interval that I'm checking in the middle. So if I go to like pi over 4 or something in here, they are both positive. So that would come out positive for f prime, which means f is increasing, right? Positive. If I check between these, I would check like pi if it were me. Right, cosine of pi is -1, sine of pi is 0, so I have -1 times 1, which would be a negative number. So that means f is decreasing. Between 7 pi over 6 and 3 pi over 2, I'm going to choose 5 pi over 4. So negative root 2 over 2 is negative 0.707. So this would be a negative times 2 sine of negative root 2 over 2 would just be negative root 2, so times a negative. So this is a positive interval, which means I'm increasing. And between 3 pi over 2 and 11 pi over 6, I would choose 7 pi over 4. So I still have the root 2's that I'm thinking about. Cosine is positive there. Sine is still negative root 2 over 2, so I have a positive times a negative, which would be a negative interval. So this is decreasing. And then bigger, we don't have anything good in there, do we? Cosine of, well, I could check 2 pi though, because that is within that interval, and I don't have a 0 at 0. So if I check 2 pi, cosine is 1, sine is 0, so this would be a positive interval. So I am increasing. All right. So decreasing, increasing. So I'm increasing from, let's see, 0 to pi over 2, and then from 7 pi over 6 to 3 pi over 2, and then from 11 pi over 6 to 2 pi. All right, got them all? Got them all. Because f prime is greater than 0. Decreasing pi over 2 to 7 pi over 6, and 3 pi over 2 to 11 pi over 6. Because f prime is less than 0. Right? This is what we are looking for. That answer would probably be worth something like 4 points, because we'd probably do 2 points for the intervals. Sorry. That'd probably be worth 6 points. I would probably give 2 points, 2 points, 1 point, 1 point. Right? We need to give our justifications as well on these things. Okay. So essentially, we've been doing the same thing all along. The only difference that I'm going to add now is identify any relative extrema. So to identify the relative extrema, all that we are going to do is essentially use the fact that if I am going from increasing to decreasing, or vice versa, right? If I have increasing to decreasing, this was a maximum point. If I have decreasing to increasing, this was a minimum point, right? Max, min, and then we're going to have to add the justification piece in there as well. Okay, sorry, this is a really big topic, so this video might be kind of like the first ones, where it's just a little smidge longer than the others. But that's okay, because we love me some calculus. All right, so find the critical numbers, same thing we've been doing. Find where it's increasing, decreasing, same thing we've been doing. Then use the first derivative test to identify the extrema. Notice it says relative extrema. I'm not talking about just absolutes. I also have an open interval, so this is kind of anywhere that I could possibly be. I don't have to check any endpoints or anything like that. So with this, I'm going to find my critical numbers first. So negative 6x minus 4. So I only have one critical number at negative 2/3. That is super, super sweet. All right, so if I check on either side of negative 2/3, I have an f prime and f to help me think about how these things interact. So if I put in negative 10, this will come out a positive interval. Again, I'm substituting it into my derivative, which means I'm increasing, so I'm going up. Going up, yo. If I put in 0, I have a negative, which means I'm going down. So this must be a maximum point. And then I don't have a minimum because it's a negative parabola, so I have Chupa-do. Right, it's going down in both directions. So this thing is increasing from negative infinity to negative 2/3 because f prime is greater than 0, decreasing negative 2/3 to infinity because f prime is less than 0. And then I can say that there is a relative max at x equals negative 2/3 because, so now here's the thing, is that I know it's a maximum because I'm going up and then I'm going down, right? So what I have to say is that I'm going from increasing to decreasing, but what I like even better is because f prime goes from positive to negative. Let's not use the shorthand in our justifications. Don't be lazy, like me, to negative. So that tells our reader that I'm using the first derivative test. I'm not basing it on my function. I'm using the first derivative test, like they are asking me to state that since the first derivative goes from positive to negative, this must be a maximum point. Cool? Yeah, I don't have any questions. But if you do, seriously, contact me. Bring it on. Okay. So here, all right, same sort of idea with my function, 2/3 x to the negative 1/3. So this would simplify to 2/3 cube root of x. So I only have one critical number, and that critical number is x equals 0 because that is where I have an undefined slope. So on my candidates test, I'm only going to check around 0. I have this would be negative, oops, right, for f prime, for f, negative, and decreasing, positive, and increasing. So I'm going from down to up, so that means I have a minimum point. So I'm going to state all of my intervals. Oh no, apparently it doesn't want me to. So decreasing from negative infinity to 0 because f prime is less than 0. Increasing from 0 to infinity because f prime is greater than 0. And then I have a relative min when x equals 0 because f prime goes from negative to positive. Right, and that is the justification that we will be looking for. Again, make sure that you note, this is important because I've seen so many kids mess this up in the past. If I'm using the first derivative test, I need to use my first derivative to justify whether I have a max or a min and whether I have an increasing or decreasing interval. We're going to get into something in the next section called the second derivative test where we're actually going to be able to tell maxes or mins from the second derivative as well. Okay, moving on. All right, we're almost there, I promise. I need to take a break for just a second, which you won't know. It'll be just a second literally for you. All right, here we go. I had to take a break to play some frisbee with one of my ACTEC students. It was a good time! Let's do some more calculus. Okay, so right, we are finding the relative max and mins. So I need to first recognize that this function has a vertical asymptote at x equals 5. So that means nothing's going to be going on at x equals 5. So really, truly, this graph, I don't need to do that much because there are no maxes or mins. Right, if I think about this graph, I have a horizontal asymptote at y equals 1, vertical at 5. I will have a graph that looks like this, right? So there are no max or mins, and it should be decreasing the entire time. But let's use some calculus to prove it a little bit. Right, so f prime is low d high, so low d high minus high d low all over low squared, which will simplify to negative 5 over x minus 5 squared. So really, truly, again, that's all that I need to see, because I have negative 5 over some value squared, which is always going to come out positive. So I do have a critical number at x equals 5. So if you want to, you can throw it on your candidates test. So at 5, you will see that you are negative on both ends, which means f is going from decreasing to decreasing the entire time. So decreasing negative infinity to 5 and 5 to infinity, because f prime is less than 0. Right? And that's the only thing that we are going to get. You could say no max or mins, or no extrema, is probably the better way of saying it, because f prime never equals 0. That's just not possible. So that means it's not changing directions, there's no endpoints, so there's nothing really to test. All right, moving on. So with this one, I don't have, well, I have a vertical asymptote kind of at 0, right, because ln of x has to be a function that looks like that, but since it's negative y's, so it'll actually go the other way. But let's just take a look with our derivative test. So f prime is x squared minus 1 over x. Right? No, Pittsburgh, Pennsylvania, I am not talking to you today. So I would have x squared, x cubed minus 1 over x is f prime. So I have x cannot be 0. And then I would have the places where x squared or x cubed minus 1 is equal to 0, which will factor, if you remember some algebra 2. Right? And then that part will have no zeros. I do believe. Will it? B squared minus 4ac. Right, those are all imaginary zeros from that part. So there's not going to be any zeros from that factor, so this factor doesn't affect me too much. But I will have an x equals 1 critical value for this function as well. So on my candidates test, I have 0 and I have positive 1 that I need to check around. So let's see, negatives, f and f prime. Negatives will come out negative when I substitute them in. Right? Say I choose negative 1 or something. That's negative 1 minus 1 over negative 1. Oh, good thing I looked at it, right? Because it's positive. Oops. Oops. So that means that is increasing from 0 to 1. Say I choose 1/2 or something. So that would be 1/8 minus 1 over 1/2. So that would come out negative, which means I'm decreasing. And then anything greater than 1, I do not believe is going to be, hang on, we'll think about this in just a second. Because I do need to think about my domain on this as well. So if I choose 10, that's a positive over a positive, so that is a positive interval. Right, so now this would be increasing. And I do need to think, like I said, I need to think about my domain on this thing. The domain for ln is normally 0 to infinity. Right, but since it is negative, that means it reflected over the x-axis. So this has domain anywhere there. So the only domain possible is 0 to infinity. So I'm going to keep only these parts. So I have decreasing from 0 to 1 because f prime is less than 0. I have increasing from 1 to infinity because f of prime is greater than 0. And I have a critical value, a min, at x equals 1 because f prime goes from negative to positive. Right, and we can check this as well, x cubed over 3 minus ln of x. And if I look at my graph, right, I don't have anything less than 0 for that thing. And I do indeed have a minimum at x equals 1. All right. What is going on? Okay, so with this one, I need to check and make sure I'm differentiable first at 0. But f prime would be 3 minus 2x and just negative 1. So at 0, I am not differentiable there. So if I have a min, let's think about this graph. 5 minus x, x is greater than 0, 1, 2, 3, 4, 5. That's that part. Negative x squared, 0. The zeros would be zero and positive 3. So I would have a graph coming up like that, right, where that left-hand side is a quadratic. So I don't have a max for this part, but I do have a max right there. And then my endpoints are nothing. So my candidate is x equals 0 because I am undefined there. Because when x is less than 0 and when x is greater than or equal to 0, if I check 0, the slope coming in is 3, and then the slope going out is negative 1, so they are not equal to each other, so that is a point of non-differentiability. So that is a candidate. And then I don't have anything else. I'm just checking around that. So at 0, right, if I substitute in, I have f prime, I have f. If I substitute in negative 2 or something, that's going to my top function, which would come out as a positive value. Yep, so that means f prime is increasing, and I can see it is. If I substitute positive 10 or something, it's always negative because it's just negative 1, so I have decreasing. So I would have a max at 0. So I have increasing from negative infinity to 0 because f prime is greater than 0, and decreasing from 0 to infinity because f prime is less than 0. And I have a max at x equals 0 because f prime goes positive to negative. Right? All right. So for these, I'm going to get rid of this part because we've been doing this all along. Let's just find our relative extrema. So f prime would be cosine plus sine. And if I set it equal to 0, it would be where, you can do this either way. You could say negative cosine of x equals sine of x. So that's essentially where they have the same value, but they're the opposite signs. And that's going to happen at 3 pi over 4 and 7 pi over 4. Because they're both positive in the first quadrant, both negative in the third quadrant. So they have opposite signs, but they're both root 2 over 2 in the second and fourth quadrant. right? So that would be my extrema. So if I think about them and how they interact on a number line using my candidates test, f prime f 7 pi over 4. Right, if I plug in 0, say, and notice I was on the interval 0 to 2 pi. So if I put in my leftmost endpoint, you could do pi over 2 as well. Pi over 2 is also a good one, right? Because sine of pi over 2 is positive 1, cosine of pi over 2 is 0. So this would just be positive, which means I'm increasing. So going up. And then between 3 pi over 4 and 7 pi over 4, I would choose pi, which means I would be negative. So decreasing, so I'm going down. And then bigger than 7 pi over 4, you could do like 11 pi over 6. So you would have root 3 over 2 minus 1/2, which would be, oh, that would be negative, right? 1 pi over 6, yeah, root 3 over 2 minus 1/2, 0.866. Oh, I thought about that wrong. 66 minus 0.5, that is positive, I'm sorry. So I'm increasing. So that tells me that, right, this value is a max, this value is a min, and then you would state because f prime goes from increasing, or sorry, from positive to negative, and then f prime goes from negative to positive. So all of the justifications are all of the same as we've been doing on these last 1, 2, 3, 4, 5. So keep your justifications the same. I'm just trying to save you guys some time and just show you different functions because we're already 32 minutes in, right? So that's how you would work with this function. Okay. All right, and that would not be my answer. So don't assume that that is my answer. That's not how I'd answer the question. Make sure you take the time and think about how you would answer the question. But again, it's all the same from A through E up there. All right, this one is a concept that you guys get in pre-cal, but you kind of don't at the same time. So the double angle here is something that we are going to need to mess with a little bit. So if I look at my derivative, f prime is 2 sine of 2x times cosine of 2x times 2. Right, so that's using the chain rule there, which is the same thing as 4 sine of 2x cosine of 2x. So now this thing is going to equal 0 when sine of 2x is 0 or when cosine of 2x is 0. So that's what I'm going to be solving for. Right, so the thing here is we don't know how to mess with double angles. But what I can do is I can solve for the angle 2x and see what that is. And then I can go through and divide my angles by 2. So if I'm dividing my angles by 2, the trick here is that I actually need to go around the unit circle twice in order to be within this interval up there. So if I want to stay between 0 and 2 pi, what I'm going to do for 2x is I'm going to go from 0 to 4 pi, so that when I divide by 2, I'm back down to 0 to 2 pi. So if this were a 3x in there, I would go around the unit circle 3 times, and then I would divide all my angles by 3, and I would stay between 0 and 2 pi. Right, so from 0 to 4 pi, sine is 0 at 0, pi, 2 pi, 3 pi, and 4 pi. These are on my endpoints that are not included, because I'm only going from 0 to 2 pi. It's not included. So I will not include those in my answer. Cosine is 0 at my pi over 2's. So all of those points. So now to get the actual angle answers, I'm going to divide everything by 2. So I have pi over 2, I have pi, I have 3 pi over 2 for this one. Then I have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So this one's just tedious because we have a ton of candidates. But it's not so terrible as long as you know how the unit circle works. So let's go in order. I have pi over 4, I have pi over 2, and then I have 3 pi over 4, and then I have pi, 5 pi over 4, 2, 3 pi over 2, and 7 pi over 4. Right, 1, 2, 3, 4, 5, 6, 7, and I have 7. So if I choose something less than pi over 4, I would choose pi over 6, and see how it interacts with both of these. The nice thing is I'm just thinking about positives and negatives. Hang on. All right, so if I put in pi over 6, right, and between pi over 4 and pi over 2, I would choose pi over 3. So half the battle is just picking good numbers to pick. So you would have your f prime line and your f line. So between pi over 2 and 3 pi over 4, 5 pi over 6 is good. And then 2 pi over 3 is good. And the nice thing is that since these things are repetitive, right, I'm doubling the angles. If I go from here to here, that's essentially one rotation about the unit circle. So all that these are going to do is just repeat that same rotation. So if I can figure out those first 4, it makes my life a lot easier. So if I put in pi over 6, sine of 2 pi over 6 would be pi over 3, which is positive. Cosine of 2 pi over 6 is also pi over 3, which is positive in that quadrant. So all I'm thinking about is ASTC. Right, so with the first one here, with this pi over 6, I am in the first quadrant with both of my angles. That means I have a positive times a positive. So this would be a positive interval, so I have increasing. If I put in pi over 3, so now I am thinking here, if I do 2 pi over 3, that is in the second quadrant for both of my angles. They are opposite signs, so I know one is positive, one is negative, so they will multiply to be a negative, which is decreasing. If I do 5 pi over 6, that would reduce to, well, be 10 pi over 6, which would reduce to 10 pi over 6, 5 pi over 3. What did I do? 10 pi over 6, 5 over 3, yeah. Oh, because 5 pi over 6 is not in there. That was dumb. That was really dumb. You guys, you can call me dumb. It's okay. 5 pi over 6 is in here. 2 pi over 3 is in here. Yes. Sorry. All right, so 2 pi over 3 would be 4 pi over 3, which puts me in that quadrant. They're both the same, so they will multiply to be a positive. And if I am 5 pi over 6, that would be 10 pi over 6, which is 5 pi over 3, which puts me in that quadrant. So I'm negative. And then it will repeat, right? So this was the first quadrant, so this will also be the first quadrant in there. I have positive and negative, positive and negative. So a lot to show, and we would have a lot of mins and maxes, right? Because I would go increasing to decreasing to increasing to decreasing to increasing to decreasing to increasing to decreasing. You are not going to have something this big on the any quiz or test. We would probably, if I gave you a problem like this, I would probably limit it to like 0 to pi over 2. I would make it a very, very small interval. It is still good to know this trick, that you can double the angle, then half the angle, in order to get some solutions. That's going to be super useful as you guys go into BC calculus as well. All right, I think this is the last one. Look at that. It only took us 40 minutes. All right. So an equation S of t represents the motion of the particle on line at any given time t. Bigger than 0. Notice our interval bigger than 0. That's always important to pay attention to. If we don't have it, then we can have negative time. Identify the times when it's moving in a positive and negative direction and when it changes direction. So essentially we're doing the same thing. It's just applying this. So we've gone over it a few times in the test. We did it, oh gosh, very beginning unit 2. But the first derivative of your position is your velocity function. They also like to see this connection made on the AP test. Fun fact is if you just say that the velocity is negative 3t squared plus 12t plus 2, you actually don't get credit for that first derivative. you need to make the connection for the readers that the first derivative is the velocity. Yes, it's implied, but they want to see that connection made. You get a point for actually doing that connection right there. It's kind of wild, but you do. So then I want to find when it's 0, right? Because that'll be when the velocity is 0, so that's when it's changing directions. So I would factor this. I'm going to probably factor out a negative first. So really I'm thinking in my head that this is 3t squared minus 12t minus 2. So let's see if it factors. That doesn't look like it will. So that would have to be plus 1, so that doesn't factor. Maybe I'll type my equation on. Alright. So what I would do at this point is find your t's in your calculator. Teesh, you messed up my zoom window on my calculator. I have to wait. Zoom square is zoom 5 if you want to do that. Oh, that's not what I want though. I want zoom standard, which is 6. Come on, Natish. Alright, so it looks like I have 2 zeros, which I should with any quadratic. I guess not any quadratic. Alright, so I get one solution to be, that's not a pen, negative 0.160247, which is no bueno because of my interval. So the only solution that I have would be 4.1602. So at 4.1602, I'm most likely going to change direction, but let's verify. Right, so if I put in 1 or something, right, f and f prime, f is going to be positive. I did this all backwards. F prime is on my bottom. All right, and if I put in 1 to my derivative, putting in 1 right there, I would have positive, so that means I'm increasing. And then I have, if I put in, I don't know, like 10 or something, then that would be negative 300 plus 120 plus 2, so this would be a negative interval. So I'd be decreasing. So I go from increasing to decreasing, changes directions at t equals 4.1602. So now, if it's moving in a positive direction, that just means I have a positive velocity. So positive direction from times 0 to 4.1602 because f prime is greater than 0. Oh, I'm sorry, not f. Come on, call the function what it is. I'm sorry, you guys. S prime and s, because s prime is greater than 0. Had to change it because my function is called s. Sneaky s. All right, negative direction. From 4.1602 to infinity, because s prime is less than 0. All right, changes direction. At t equals 4.1602, because s prime goes from positive to negative. Okay, so big unit. It's the same thing over and over and over and over and over. Really, it's just recognizing that these are true and then knowing how to justify them and find them. Other than that, I'm going to stop talking at you guys and give you guys time to work on your homeworks, which I believe you have 2 days for. Should have 2 days for. Yeah, 4-3, you have 2 days. Okay, so if you watch this the first day, start your homework, finish your homework tomorrow. And other than that, let me know what I can do to help you guys out, and I'll talk to you all soon.